Here is the answer for the day 4 bell work. Convert the following using a formula or dimensional analysis and show the work steps. Question A, convert 200 Kelvin to a temperature in degrees Celsius. To do temperature conversion, it uses a formula. We're asked to find an answer in Celsius. So the formula is C equals K minus 273. If our known temperature is 200 Kelvin, then we need to substitute 200 in place of the K. Then do the subtraction. This is negative 73 degrees Celsius. Question B, convert 23.5 centimeters into meters. This is a metric conversion, and it's done with the dimensional analysis process. Always begin by writing down the known measurement, 23.5 centimeters. Then write times and draw a fraction line. Copy this label down in the bottom. And the one we're trying to figure out, meters, put that label in the top. Now comes the memorized knowledge that you have to have. You have to know the conversion between meters and centimeters. 1 meter has 100 centimeters in it. This sets the problem up so that when you actually solve this out and notice that the CM cross cancels the CM, leaving M, you'll know you have the right setup. Take a calculator, go 23.5 times 1 and divide by 100. That will make 0.235 meters. Now question C. Convert this amount of milligrams into nanograms. So this is another metric conversion. Write down the known measurement first. It's in scientific notation, but don't let that bother you. Just write down that entire number, including the label, milligrams. Now write times and draw a fraction line. Whatever this label is here, put in the bottom. And whatever we're trying to figure out, in this case nanograms, put that in the top. Now we're going to make our conversion factor. We need to know the relationship between nanograms in milligrams. And we'll think of that relationship in terms of how these units relate to the basic unit, grams. There are 1 billion nanograms in a gram. A quick way to write that is 10 to the 9th power. And there are 1,000 milligrams in a gram. I'm going to write 1,000, but I could write 10 to the 3rd power. With dimensional analysis, we know we have this correct setup because when we think about how this unit will cross-cancel this unit, we can see that we're left with the unit we're looking for. As long as we've put the correct numbers in the numerator and denominator of our conversion, we know we have the right setup. Take a calculator, type 2.5 times 10 to the 3rd times 10 to the 9th, and then divide by 1,000. It's going to make a large number, so I'm going to write down the answer in scientific notation. 2.5 times 10 to the 9th power. Nanograms. This particular problem could actually be done mentally. Remember how the 1,000 is the same thing as 10 to the 3rd power? That means that this 10 to the 3rd power would cross-cancel with this 10 to the 3rd power. And you'd just be left with the 2.5 and the times 10 to the 9th.